Session recording is starting now.
Ashish, I think we should start.
Yeah.
Okay, can I share the PowerPoint?
Yeah. Just I will share this one. Then after that, good afternoon, everyone. Guten Abend to all my German friends for this great evening at India. This is Indian Plumbing Association, that is IPA, and IPA is started 27 years back, that is in 1993, and we are having around more than 4,700 members across the India, having 23 chapters across India. Nagpur is one of the chapter, and 2 years back Nagpur was chartered, and we are having membership more than 100. In last this COVID situation, in lockdown situation, we organized 6 webinars for the benefits of our members and the fraternity. And in line with that one, today we are having the webinar on lake rejuvenation and beautification, that is lake therapy. Ashish, next slide, please. What IPA is doing. Ashish. This is the disclaimer of today's session. Whatever the contents given by Juliana will be her views, and IPA is not having any responsibility of that one. Next slide, please. Now, IPA organizes many events, of which WPD, that is World Plumbing Day, which happens to be in the month of March. So we do many activities on World Plumbing Day in the month of March. World Plumbing Day happens to be on 11th March, but we consider the month of March as the WPD month. Apart from that, IPA organizes the Indian Plumbing Conference every year, and this year it is scheduled in the month of December at Pune. So this is the 27th IPC, which is going to happen. Apart from that, IPA organizes the IPPL, that is Indian Plumbing Professional League. So this is this year it will be the 4th edition. 3 editions happened, but this edition will be something different because of this lockdown situation and the COVID situation. So this year it will be in the online platform. Last 3 versions were different. This year will be. Anyway, we will share the details about it. Apart from that, IPA runs the mission of I Save Water, and in this there is a big mission. Last year we saved more than 500 lakh crore liter water, and this year also it was the mission, but because of this lockdown situation, now it is suspended till that for some more time. And again, once the situation comes back, so again we'll be on the mission. Again, apart from that, there is a monthly magazine, that is Indian Plumbing Today, where a lot of technical knowledge getting shared, our case studies and innovations are there. So this is monthly issue, but anyway, from last 2 months, it is also suspended because of the lockdown situation, but very soon again we'll be back. Next slide, please. Apart from that, IPA has issued guidelines, that is remedial measures for the plumbing system after COVID-19 situation and other infections. So please go to IPA website and you can download. It is a free of cost, and you can imply in your day-to-day regular things after the COVID situation. Anyway, now I told about this IPT, which is right now locked. lockdown situation, it has not come, but anyway, very soon we will be back in situation. Next slide, please. So please follow us on www.indianplumbing.org. We are also available on Twitter, Facebook, and LinkedIn. And now today is the day. It is 8th June is the World Oceanic Day, Ocean Day. So now this reminds us that the major role of oceans have in everyday's life. They are the lungs of our planet, providing most of the oxygen we breathe in the end. It is a day to celebrate together the beauty, wealth, and the promise of the ocean. As we cannot discuss on the ocean, so today we are discussing on the lakes. And Juliana is going to take us in detail about the lakes, what are the pros and cons, and what we should do. So anyway, now to celebrate the World Ocean Day, we have organized this event. Apart from that, just it is my request that today please skip the seafood. And today, as we have gathered, this is also celebration part. We all friends are there. We have gathered today for this World Ocean Day. Again, one more request that we should avoid the single-use plastics, deep breathe, and appreciate the ocean. This is the thing. Apart from that, now today is also one of the very special day. It is generally we have celebrated the Friends Day, Friendship Day, but today is the Best Friends Day. That is also there. We are now we are best friends, and that's what we come together for this event, and we should honor our closest and dearest friend on this day. So now uh, we are going to gain a lot of knowledge about this one. Uh, so now let us pray to the God and by lighting the virtual lamps and gain the knowledge. Over to Ashwin to introduce Juliana for this wonderful session. Ashwin.
Hello, am I audible?
Yeah.
Yeah. A very good evening to all of you. I would like to introduce Juliana, today's speaker. Juliana studied biology with emphasis in ecology at the Federal University of Rio de Janeiro, Brazil, where she obtained her master's degree. She has been in Germany for 5 years and is currently finishing her PhD thesis at the Technical University of Munich. Lakes and freshwater environments were always the focus of her research. Last summer, she joined OSCE as an expert in the biotechnology team. I welcome Juliana for this session, and I'm very much sure that we will have a pretty good experience with your experiences. Thank you.
Thank you for the nice introduction. Can
Thank
everybody
you.
hear me?
Yeah,
And
yeah, audible.
are you able to see my presentation now?
No, you have to share the screen.
But I was already sharing it. No?
Ashish, please see that. Right.
Um, it says here that someone else is trying to share some content and I cannot share
I
my.
already stopped. I already stopped. Can you
Okay.
try once again?
Yes. Can you see it now?
Yeah, yeah,
Yeah.
it is visible now.
Okay. Do you see it in full mode?
Yes.
Okay. I would like to ask you to mute yourselves while I talk, and we will have time in the end because this will not take 1 hour. So you can ask questions for sure. But for the moment, it would be better if you just mute yourselves because it's a lot of noise. Yeah, thanks for the nice introduction. I'm Juliana, as you presented me already. I don't think I have to talk about myself. And today we're going to talk about lake therapy. I want to present some of the challenges that we have and perhaps some of the alternatives for sustainable restoration. So here I'm going to present you just a short index so you know what's coming next in our presentation. I will start with the importance of natural lakes, of course, in our planet. And then I will focus on the process of eutrophication, causes and consequences. So here we have many factors. You probably know most of them. And then finally, I'm going to go into our main topic, which is lake therapy, the non-treatments, problems, and then the available alternatives. So to start here with the natural lakes, I would like to define it for you. So those are water bodies that occur naturally in the terrestrial ecosystems. And I would like to present you this map. Here you can see the distribution of small lakes on the planet. Those lakes have between 1 to 10 square kilometers surface, which means they are smaller, but they represent a lot of the lakes in the total number. And there are many, many lakes in the tropics, in South America and also in Asia. And lakes are very important in the terrestrial ecosystem because they also accumulate a lot of organic material that comes from the surface of the earth. So here in this figure, you can see the number of carbon that is accumulated in the inland waters. This is 0.6 pentagrams carbon per year that is accumulated in inland waters. In the past, it was believed that lakes and rivers were just a plumbing system. Organic matter would go from the terrestrial system through the lakes and rivers to the ocean. But now we know that those systems are also reservoirs of organic matter, especially on the sediments. And this is very important because there is a lot of degradation occurring in the lakes. So besides that, natural lakes are an important habitat for many aquatic and also terrestrial species. They go there for reproduction, for feeding, etc. It's a fresh water source for many cities, many regions. You need lakes to drink water, to use water in your households. Besides that, you can also do sports, use lakes for recreational use. It could be a food source, fishing, for example, other organisms. You could also do some cultivation. And of course, they have economical value, not only because they could be freshwater or food source, but also because of the landscape. Sometimes it's very beautiful and it's also a touristic attraction. But recently, in the past decades, years, we've been seeing a lot of eutrophication happening in natural lakes. And eutrophication could be explained as the increased amount of nutrients in the freshwater systems. And in the first moment, the nutrients, the exceeding nutrients, comes from an external source. So probably wastewater or agriculture, cattle, fertilizers, they would be leached out into the systems, increasing the amount of nutrients and promoting algal blooms because algae would use these nutrients to do photosynthesis and increase their growth rates. But then, once you have algae, a lot of algae already inside your system, they will someday die. And the material from the algae, the dead algae, would be degraded and nutrients will be released again. So you have an internal source also. And therefore, it's so important to talk about lake management because sometimes, even if you reduce your external input, you of course have to do with policies, management of the watershed. It's a lot of political influence going there. It's really important. We need to reduce the external sources. But even if we do so, we already have a lot of internal sources by that point. And eutrophication is usually thought about the increased concentration of nutrients. And here we are talking mainly about nitrogen and phosphorus. But phosphorus is the limiting nutrient. It's the first one to be used by plants and algae. Therefore, these concentrations are very important. It doesn't really make a lot of sense to just measure nitrogen alone, because if the plants and algae doesn't have phosphorus, they're not going to do photosynthesis and they will not grow. So usually what happens is that we use the phosphorus content in a way to estimate which is the trophic state of the lake. If there is a high level of phosphorus, for example, here we can see you can characterize the lake as eutrophic or even hypertrophic. But if you have low levels, then you have oligotrophic waters, ultra oligotrophic waters, the ones that you don't have a lot of nutrients available. And as I was saying, one of the first things that we realize when we have a problem with eutrophication is algal blooms. So it is characterized by the intensive growth of both harmless and harmful algae. That means that sometimes there are species that are not harmful at all for other organisms or for humans, but it's not an equilibrium, if you have a lot of them there. But some species are very harmful and could be highly toxic even to us. And the most famous is cyanobacteria, which is actually a bacteria, but we call them blue algae or blue-green algae, and it has a lot of competitive advantages in comparison with other algae species. It's highly efficient in carbon dioxide fixation. It could also fix nitrogen from the atmosphere. It is capable of storage phosphorus, and it can make spores, which means it could last forever, a long time in the environments. And when humans get in touch with cyanobacteria, we can have a lot of symptoms: headaches, allergies, even neurotoxic effects. So it's really dangerous. We should not swim, drink the water, get the fish. Everything, it's really limited when you have those kind of blooms. And if you have a lot of algae, they are doing a lot of photosynthesis, right? But they are also doing a lot of respiration. Their metabolism is high and they are dying. Remember, the algae at some point will die. And this will increase the microbial metabolism as well and lead to oxygen depletion. So, as I said, the increased metabolism will lead to the increased consumption of oxygen. And later on, this increased microbial metabolism in the water column and in the sediments will make the lake anaerobic completely. It could be a recurring issue, not only in the warm environments, but especially there, because microbial metabolism is favored in warm temperatures, but also in Europe or other countries during summer. So here, just to show you how it works in summer or warmer environments such as India or South America, if you have temperature stratification in the lake, you have layers. Those layers will not mix to each other because warmer waters are on top, cold waters are on the bottom. And therefore, the oxygen is also kind of trapped in those layers. So there is no mixing in the water column, and oxygen will not get to the bottom. Differently, in autumn or spring, you can have an overturn because the water, it's more, the temperature is more equal in the water column. You don't have this stratification. Therefore, the oxygen that is in the top could reach the bottom and avoid this complete anaerobic system that you have in the sediments. And here from this study, you can see the difference that it makes if the lake is oligotrophic, as I said before, without a lot of nutrients, or if it is eutrophic. Here on the left of the screen, you have three graphs. The first one, A, is from Quellitzsee. is a very oligotrophic lake in Germany, very clear waters, and you see the oxygen profile. Over 100 meters, you still have oxygen on the bottom of the lake. On the other hand, if you go to the last graph, letter C, there is another lake in Germany, Plussee, which is eutrophic. And even though you have measurements up to 25 meters, oxygen is gone by 5 meters. So you don't have oxygen reaching the bottom of the lake. On the other figure on the right, you have the depth profiles of oxygen in the same lake, the eutrophic one, but in different months. So you can see that in August, which is highly warm in Germany, oxygen is depleted very fast, while in colder months, you could see oxygen reaching the bottom of the lake. And if you don't have oxygen, many animals will die. And here in this context, I think fish mortality is quite important. So, as I said, fish and other aquatic organisms will die without oxygen. They cannot breathe. And this represents biodiversity loss because some species are endemic for a place. Maybe you lose this species forever, you don't know. Sometimes it represents loss of resources, food, and also financial loss, of course. And the landscape is also deteriorate. As I said, it's not nice. It's not beautiful. If you need tourists to go to this lake to use it as bathing spot or sports spot, you cannot do it while you have hundred thousands of dead fish in the water. And also the smell. So it's also a really important problem. And when you have a lot of algae and a lot of fish and they're dying, you have a lot of organic material. And this organic material would probably sink in the bottom of the lake, resulting in the silting up process. So when we say silting up, we are talking about organic material. This is specific. We are talking about a sludge layer that is getting more thickened over time. When we talk about inorganic material like sand or some other soil that it's coming, then we say sedimentation. So those are two different processes, and here we are focusing on the organic material. So as I said, this process is accelerated by eutrophication. And when you have this accumulation of organic material in the bottom of the lake, you would have the thickening of the sludge layer, a lot of microbial degradation, and again, you could have the loss of oxygen and other processes will go there. I'm going to explain it a bit later. Oops. So here in this figure is just to make it clear how everything is connected, what I just explained, even from the other processes. First, you have phosphorus coming from external sources, diverse sources, and this will lead to algae to grow intensively. And the algae would lead to fish and other animals. If you have a cultivation, you probably are adding fish food to the lake, and both algae and fish are gonna die at some point, and you would have dead organic matter, decaying organic matter. And this biomass of organic matter that I just explained will be later on decomposed. And the degradation of organic matter will remineralize the nutrients. So nutrients that were before in the organic matter will be then free, available in the water column, leading to more algae to grow. So yes, you have an external source, but then the system, it's feeding itself. And when you have more sludge in the lake, you have less water volume. The water column is not so deep, and the water column is the habitat for many species. And the sludge also acts as a reservoir of nutrients. Many nutrients are binded there, and they could be released at any moment. And as I said, the lack of oxygen in the bottle also promotes greenhouse gases production. For example, methane is a greenhouse gas which has a higher potential than carbon dioxide, but it's only produced in anaerobic environments. So if you don't have oxygen, you will for sure have methane production. And when you have oxygen, you won't have it. And another anaerobic reactions could also produce sulfur gases, which have a very foul smelling. Those are kind of the main problems that we can face. And there are other problems. I just made a short list. Of course, maybe you know even more from your experience, but we could have acidification. It's mainly discussed in the oceans. As he was saying, today's Ocean Day, so here some example. Browning, also it's happening a lot. Erosion, drought, heavy metals contamination. So just to name a few common issues that we see every day in many natural environments. So how are we dealing with that? How are we trying to improve lake conditions? What do we know about lake restoration? So here we can see that we have methods for the whole water catchment, and we have methods in lake methods, dealing individually with each lake that we want to treat. As I said before, we need for sure to have catchment management, reduction of nutrients, perhaps some constructions, protect them from erosion. That's really important. But you also need to tackle the issues for each lake. Sometimes they are already with a lot of nutrients, and just to reduce it from outside is not enough. So you have mechanical methods, chemical ones, and also biological. I'm gonna go into a few, not all of them, but probably some that are very, very common for you. So it would be more interesting. First one I would like to talk about is liming. So liming is the addition of limestone, usually calcium carbonate. Soda ash or sodium carbonate is less frequently used because it's more expensive and also doesn't have the beneficial calcium ions. And liming is used to improve alkalinity. But why is alkalinity so important? Is the water capacity to neutralize acids and to resist the changes in pH. So it's a measure of the concentrations of three basic ions, the carbonates, the bicarbonates, and hydroxides. And although liming is cheap and relatively easy to apply, it might not be the best solution. Some types of lime are corrosive, for example, quicklime. And sometimes we need to ask ourselves if acidity is the real issue or not. Are you measuring the pH throughout the day? Because there are normal variations depending on the sunlight and the amount of photosynthesis there is happening. Some variation is normal. So if you just measure at one period, maybe you don't know exactly what is happening in your system. Another issue is how to calculate the right doses. So you have to take in consideration the conditions, all the organisms, the pH that you want to set, the material quality, and so on. And liming, it's not recommended for naturally acidic environments, for example, wetlands, because those environments already evolved in that way. All the organisms, they are adapt for an acidic environment. You don't want to mess up with that pH. And another aspect is that, oops, sorry. Liming could also release absorbed elements, for example, phosphorus and carbon, which would trigger eutrophication. And we saw before that eutrophication is something we really want to avoid. So what could we do alternatively? Perhaps if we add the correct amounts of calcium and carbon dioxide, we could create an ideal environment for all fish, plants, and pond inhabitants. Because if the pH is always high, if you measure all over during an entire day, and it's always above 8.5 to 9, or if you have strong fluctuations that are not natural, it could be a lot of stress for all the organisms. So water stabilization improves the water quality, allowing the ecological equilibrium. So if you have ecological equilibrium, we'll have not only good environment for fish, plants, but also for zooplankton, for example, Daphnia. And those microorganisms, they eat algae. So they help in the control of algal blooms, and they support the self-purification of the pond. Another method that it's quite common to fight algae as an algaecide, it's copper sulfate. It's used to control, but sometimes it's not treating the real cause of the algal bloom. It accumulates as a heavy metal and it's not biodegradable. So it could also bring harm to the pond, to the other animals and plants that live there. So you would have a wicked aquatic food chain, killing the microorganisms, and besides that, it could also be harmful to humans. And symptoms here range from burning pain to diarrhea and even headache, skin issues. And finally, copper sulfate is highly corrosive. So what we have as an alternative to control the algae bloom is to prevent and eliminate green algae, cyanobacteria, and also thread algae with more sustainable methods. I think the goal is to avoid using strong chemicals. We don't want to damage the lake while fighting the algae. We don't want to damage the environment for other animals and plants. Therefore, one method that it's very efficient is the use of a technology that blocks specific UV wavelengths. As you can see from this graph, depending on the chlorophyll that the plant or algae has, it is absorbing a certain wavelength. If you block this specific wavelength, then the algae is not able to do photosynthesis and it will not grow exponentially and you would not have algal bloom. Besides that, if you release active oxygen in the water, you would do immediately oxidation and destruction of the cell structure of thread algae. And you would also kill the mold that lives in symbiosis with these algae. Another treatment that we have, this one is to remove phosphates via precipitation, is to add aluminium sulfate, usually called alum. The precipitate is supposed to stay unavailable at the bottom of the lake, so it would precipitate, stay on the sediments, and not be available for further algal blooms. However, changes in pH can release free aluminium in the water again. And aluminium is not biodegradable and might be toxic for wildlife as well, fish and other organisms. So as an alternative to phosphate binding with alum, we could have the conversion of phosphates into apatite. Apatite is a mineral which is insoluble and it's not harmful either to fish or other living organisms, neither to us. So it cannot be assimilated by algae, but it could be absorbed by aquatic plants through their roots because they have some symbiosis with fungi that are able to do the weathering of this mineral. And if the algae don't have phosphorus, they won't be able to grow. So here you prevent the reason for the algal bloom, directly starving the algae. And there's no use of iron or aluminum compounds, so it's totally safe. And there are no harm for the other organisms. And lastly, one of the most common mechanical methods to treat lakes is dredging. It's usually done when you have a lot of sludge and you want to make it cleaner, but it's also very harsh on the environment because it's a very aggressive method. So first you have the impairment of the surrounding environment. You have some destruction on the margins. It's a heavy machinery. And second, when you remove the sludge and the parts of the sediment, you have a degradation of the benthic habitat. So all the zoophytobenthos that live in the sediments, they lose their homes. In a second moment, you would also have the resuspension of organic material and nutrients. Some stuff that were just resting there in the bottom of the lake will be again in the water column. As I said before, sediments are a reservoir of nutrients. And if you put that up in the water column again, this will be available for the bacterial to the microorganisms, will be remineralized, and again, algae will be able to use it. And besides, dredging could be highly expensive, take a lot of time, and in the end, you still have to dispose this sludge somewhere. So you have to do it really carefully where to put the sludge, which end this would have. So as alternative methods to remove organic sludge, we could think about chemical and biological methods. If you add mineral compounds that release oxygen at the bottom of the lake, the levels of oxygen would favor microbial sludge degradation because, as you probably know, all degradation runs faster when you have oxygen. Anaerobic processes are much slower. And at the same time, this will trigger the same reaction that I said before that binds phosphate. Phosphate will be converted to apatite and therefore will not be available to algae. And if necessary, you could also add some microbial component to that treatment. So there are natural bacteria in the sediment lakes, in the lake sediments, and if you just add a bit more from these cultures, it's super safe. It's nothing that you don't have in the lake. You would accelerate the degradation process because you would have a bigger community to degrade the organic matter. And this could promote long-term degradation up to several weeks. So it's not something that just solves the problem for 1 week or for that moment, but that on the long term will increase the water quality and of course the amount of sludge that you have. So what I just described, we can say it's an environmental friendly treatment because it's biodegradable, you have no accumulation of residues like aluminum or copper sulfate. You neutralize harmful metals and you prevent the formation of harmful gases like greenhouse gases or sulfur gases. You have no impairment of microorganisms from the sediment or in the water. You have the protection of the flora, of the fauna, of the whole system. You don't have to find a place to dispose large amounts of sludge. It's possible to do this treatment inside protected areas Sometimes you need a permission, but it's way more invasive than dredging. And although the application is done in a few days, you can see a result in the long term, preserving nature, plants, animals, and the equilibrium of the environment. So to summarize, I've been talking a lot, I guess. Lake restoration is kind of a holistic treatment, should be treated as a holistic treatment because you have to tackle the problems through different angles. So first, you need to have stable water parameters because that's important for all the organisms living in the lake, both animals and plants. And then if you have already a lot of nutrients leading to algal blooms, you have to tackle this. You have to combat the algae growth. And lastly, you have to bind the excess of nutrients. For me, it makes more sense to bind the nutrients in the end. This would be like the final step because when you combat algae and when you degrade sludge, you could have some release of nutrients. So you should bind it in the end. So here I'm gonna shortly present some case studies that we have from our experience just to show how successful such measures could be. This is Quellitzsee. This is a lake in Germany. It's not very big, up to 6 hectares. There was a lot of silting up happening there. The lake was already very shallow. And with this treatment, this natural treatment, we could have a reduction of sludge up to 75%, which is amazing. For me, that's a very high number. Another lake is Schwanenweiher. This is a very small pond. It's in a park area. And we had fish mortality reported before, a lot of sludge. And after a natural treatment, we had a reduction of 55% in the sludge layer. And also, we didn't have any more fish mortality happening in that place. The third example is the Mühlenteich. This is also a very small lake. The sludge layer there was very thick, 75 centimeters. Also cases of fish mortality, very shallow waters, and dredging was not permitted. So this was very fortunate for us that we could do our treatments there and we could get sludge reduction of 43%. And also we measured very low levels of phosphate in the sediments. Lastly, this is my last example, Kleiner Rußweiher. This is a bit larger lake, 26 hectares, is highly visited, is a touristic spot. People use it for bathing, fishing, boating. There are camping sites on the margins. And one aspect that is very interesting is that Kleiner Rußweiher is connected to another lake, which is used for fish production. So every year it receives a lot of input from the fish lake. A lot of feces, dead fish, the food fish as well. So it receives a lot of external input every year. And even though there's a lot of organic material coming in, we still got a reduction of 22% in the sludge layer. So to summarize, what we saw is that natural lakes are of ecological and economical relevance in our planet, in our daily lives. We saw that successful recovering of natural equilibrium should be done with holistic treatments. So we need to restore the water chemistry to fight algal blooms, remove the sludge, and bind the nutrients. It's very important to take the whole environment in consideration and not just one problem, because everything is connected. Of course, measures in the watershed are also very welcome. As I said, you need to restrict the external input of nutrients. And with this, we aim to find long-term restoration. We want the lakes to be healthy. Sustainable restoration means that you're not solving the problem for a week or two, but in the long term, the system is in equilibrium. So if you need any other information, if you have any other questions regarding anything I said, you could get in touch with my colleagues here in Germany in WhatsApp, phone. Here's the phone number. And also there in India, you have also the phone number and the email. So you can also shoot an email in our colleagues here. And yeah, I would like to thank you for your attention. And yeah, maybe we can discuss a little bit.
Ashish,
Yes.
Moez, can you take the questions? Yeah, you can. You have to unmute yourself. You have to unmute. Moez, you have to unmute yourself. Ashish, can you unmute Mr. Moez?
Yes.
Yes,
Mure
yes.
sir.
You are very Julian. Hello.
Hi.
Hi, I'm asking question to you, I think.
Yeah.
Okay.
I'm a IPA member from India. And most of the places in India, we have desilting problems. Every year they have desilted by your dredging and all that. The second problem is a lot of slumps coming nearby the lakes. And the third is for beautification. I don't know the material they were using is environment friendly or not. Could you get me?
I don't know if I understood the question in the end.
No, I wanted to ask you, as you said that desilting by you're using those chemicals and all that, and how long will it take to really get the results?
Oh, okay. Depending, well, it depends on the environment. There's no one right answer for all the lakes. It depends on the size of the lake, of how much sludge you have there, how is the organic input from outside. As you said, there's lumps around the lake. Probably there's a lot of wastewater going there. So
Slumps, I'm saying. Not lumps, slumps.
slumps, yeah.
Yes.
So yeah, there's probably water, Hubert, going
And
there.
at places it is being contaminated by the drainage water also, leakage in drainage waters also.
Yeah. What we can say is that when we apply those chemicals, compounds to release oxygen in the sludge, it's usually active for several weeks. So up to 2 months, more or less, you still have oxygen release. So this will improve the organic sludge degradation for a longer period. And if you add the microbial community, this microbial mix that I said with more bacteria, this will also increase the velocity of degradation. So our aim is to, what we usually do is after the treatment, we repeat all our measurements 6 months after, and then we check, okay, what happened in those 6 months? And if necessary, then we would plan another round of the treatment.
Okay.
But usually in a couple of months or so, you can already see the results.
Okay. Thank you. Thank you.
You're welcome.
So, Juliana, we have a couple of questions in chat box. I'll take one by one.
Okay.
One is from Mr. Rao. How does lake help in overcoming the water crisis? Can lakes help in natural water harvesting?
Can lakes help? Sorry.
Can lake helps in natural water harvesting?
Yeah, this is very important because we live in a world with shortness of water, shortness of clean water, and as we know, most of the water is in the oceans and is not readily available. So, yes, natural lakes could be very important as water resource, and we should um, we should have it as healthy as possible, as clean as possible. We should do all the management of the watershed to decrease the pollution, and then this water could be used as a drink resource. But it really depends on the environment. What is the surroundings? Which kind of pollution you have? If you have industries, if you have slums, if you have a lot of urban density. So it's very tricky because not all our lakes are in natural reserves. Not all of them are protected. So it's tricky. We really need to take some time and focus on the lakes, as I said, as a holistic thing, and take into consideration the whole policies that we want to apply in the environment. Though.
Right. So, Mr. Rao, if you have a further comment, you can maybe put it in chat box. I'm going for your next question. The next question from same in line with this is, do lakes die naturally, or human mistakes are the only cause of to die lake die the lakes?
No, the thing is that eutrophication is a natural process that could happen over centuries of years that could usually happen. But nowadays, what we are seeing is the increase of anthropogenic eutrophication. So, with our external input of nutrients, pollution, and so on, we have accelerated a natural process. So, we are damaging the lakes in a way that they go to this point and there's almost no return. This could happen naturally depending on the environment. If the lake is super tiny, is surrounded by forest, it could be the case that it receives a lot of material from the trees, the animals, and at some point it would get eutrophied. That's okay, but that would take centuries. And what we see nowadays is lakes getting eutrophied in a couple of months, years. And that's not really normal. That's not natural.
Okay. So, next question again from Mr. Rao is, what are the considerations for building a lake?
Um, that's a good question. I am not very familiar with artificial lakes. Most of, yeah, I studied natural lakes my whole life, but I think if you want to build a lake, you have to consider the environment. Where are you going to build it? How deep are you going to make it? And you probably need a lot of consultancy on which kind of species you're going to uh, put in your lake. You need a community to start somewhere. So yeah, there are a lot of aspects that needed to be taken into consideration, but unfortunately, I'm not the best person to talk about artificial lakes.
Okay. So the next question we have from Mr. Prashant: how to tackle BOD and COD? So
Okay. Um, what do you mean by how to tackle, how to
yeah,
measure, or how to increase, decrease the values?
yeah, Mr. Prashant, maybe you can unmute and elaborate further.
Hi, Julia. Good evening. This is Prashant.
Hi,
How are you doing today?
fine, and you?
I'm good. Thank you. Quick question is, normally in India, what is happening is most of the lakes are getting polluted because of some leakages from the drainage and all those things, right? So the BOD and COD levels, the biochemical oxygen demand and chemical oxygen demand, they are like enormous especially in lakes, which are literally kind of stagnant, right? There is no running water in lake. So now to tackle this, the VOD levels are more than almost 600, 700, sometimes 1,000. So in this case, most of the aquaculture is dying for some of the lakes in India. So how we can reduce the BOD, COD levels, especially
Okay.
with those, yeah.
Okay, so the biological demand of
Right.
oxygen is, as I try to explain, caused by the increased organic material that you have inside. So when you have an algae growing a lot extensively, you have those algal blooms. The algae is not only doing photosynthesis, but it also needs to breathe. So it's producing oxygen, but it's also using oxygen. And the algae is dying, and over time, microbials will need oxygen to degrade those algae debris that are in the water column and slowly sinking to the bottom. So, to tackle the oxygen demand, to reduce it, to have more oxygen available, first you need to fight the algal bloom. You have to reduce the content of organic material that you have inside of the lake. But there are also other methods where you could increase the oxygen availability. You could give more oxygen at some point. But in the long term, the best thing to do would be to reduce the input of nutrients and organic material to tackle the algae blooms, and then you would have a better equilibrium.
Okay. So next question we have is from Mr. Rao. Can lakes in multiple numbers in a geography help in rising the aquifer?
Hmm. Um, I'm not really sure if I know how to answer that question, because I think from aquifers, you not necessarily need a lake. You have other ways of absorbing water through the soils. So I think the most important is also to have healthy soils. If you have forests, if you have lots of trees, their roots are going to help. If you have everything as a urban area, if everything is concrete, then you would have problem with aquifers. So it's not necessarily the lake, but it's the whole natural environment.
Okay. So the next question we have is from Mr. Ramveer Tanwar. Just want to know to best solution to remove water hygienic from the lake and how can we stop it to grow again naturally?
Um, One moment. I'm not sure if I understood what he means by water hyacinth.
Mr. Ramveer, can you unmute and elaborate? if possible?
This is a plant, right? Is a
Sure,
species?
sure. Yeah, hi Julie. It was water hyacinth. You know, water hyacinth grow in the lakes again and we remove and it grow again within 2 to 3 months. Uh,
Yes.
I'm very sad to remove it again and again. So just want to know the best solution so it cannot grow again in that lake.
Yeah. So as the algae, the aquatic plants also need nutrients. So the best way to reduce both algae and unwanted aquatic plants, macrophytes, is to reduce nutrients. You have to reduce the external input, and you can also bind the nutrients in the water column. Both would help you in the long term because, yes, if you remove it, but the main cause is still there, it will probably grow again exponentially.
Thank you.
Right. So at present, the last question we have in chat box is from Mr. Virendra Khare. The natural lakes formed by creating one from one side normally gets a water from natural storm or rains. The problem is due to natural gradients, the pollutants from the nearby habitat and industries flow to lakes. Can sewage treatment plant help in purifying the lakes?
Yeah, in that case, it's very important that you have sewage treatment before um, before any external water is leaching to the lake. That's very important because if you don't have any treatment, the sewage will carry a lot of nutrients. As we saw, the same way that fish feces have nutrient, ours has as well. So yes, you have to treat the sewage before it goes to rivers and lakes. And I think if most of the water is coming from natural rains, it's fine. Maybe you need to check how's the pH, how are like the chemical parameters. But of course, for nutrients, if you have nearby residents, you have to take care with the sewage.
Okay, so there is another comment from Virendra sir. How to maintain the potability of a lake water?
Yes, the most important thing is to keep the chemical parameters in order. That depends on where you are because different organizations have different standards. So perhaps in India is different from Germany, which is different from Brazil. So that's depending on your guidelines, but you need to keep the water parameters stable. And of course, everything we discussed before applies here. The whole nutrient balance, the equilibrium, the fauna, the flora, everything needs to be stable and functioning in the best way possible. As we explained before, algal blooms, for example, most of the times contain cyanobacteria, which is highly toxic for us, and we cannot drink water if there is cyanobacteria. We cannot even bathe in one of those lakes. So yes, it's very important to keep the nutrients low, and some chemical parameters might need to be adjusted. And for that, you might need to add some ions, some components to make a right balance. But it really depends on which kind of lake you're talking, what are the conditions. As I said before in another question, sometimes there's no one answer that fits all the lakes. Each lake is unique. Each lake is a whole environment. So, yeah.
Right.
Ashish, there is
So
there any question? No more question.
yeah, one question we have left in chat box is could you please elaborate the mechanism of reducing sludge with the treatment mentioned in case studies? What is the end form of the phosphate with the suggested chemical treatment, and in this form it is not available for the assimilations?
So this treatment for sludge reduction is based on the addition of calcium peroxide. And um, when you have the reactions, the chemical reactions there, you have the release of oxygen, and at the same time, you have the binding of phosphate. And I said it was apatite, is a phosphorus mineral, and this mineral, it's insoluble, it's unavailable for algae, would be in the sediments and will not be remineralized because it's not available. So it's not like you have a heavy metal in the sediment. It's not something that you have there that it's bad for the organisms. It's something completely inert, which doesn't make a lot of difference. And for plants that have roots in the sediments, some aquatic plants, they have roots. They have like symbiosis with fungi in the sediments, in their roots. And some species of fungi can make some weathering in apatite. But for other organisms, it will be completely unavailable. So, yeah, this is our main goal, to release oxygen and to bind phosphorus. And additionally, depending on how big is the sludge layer, we also apply a microbial component. So we grow bacterial cultures in our labs, and the bacteria that we grow is exactly the same that they're already present in many lakes. It's not something that could be dangerous or anything, but it's just to make a starter because microbial communities can be really diverse. They can be very heterogeneous inside the same lake, and it could take some time for them to grow and to adapt to new conditions. So you have sometimes a bottle of the lake that it's been anoxic for a long period, and you have a lot of sludge, and suddenly you put oxygen there, but the bacteria need some time to grow and to be, yeah, strong enough to eat all that sludge. And then if you put a little bit of this microbial component, you help it. You help the community to build up and to degrade the organic material.
Yes, sir, you had a question.
Yeah, Juliana, one thing you was telling about the oxygen depletion. At in upper level, if there is oxygen, and lower level, if there is no oxygen, then there is a chances of methane gas generation. So it is not possible to use that methane as a fuel, and we can use lake as well as the fuel generator also. Or is there any such kind of natural lakes are there?
You mean using the methane that is produced in the lake sediment as energy for
Yeah.
other? Probably. I mean, I don't know if there is such mechanism. Most of the studies with methane as energy source, they are done in bioreactors. So it's using our trash. So if you have organic trash, this rest of food, for example, you could bring everything to a bioreactor, you produce methane, and you use it as energy. But in a
Yeah.
natural lake, I'm not sure how to do it because, well, you have different gases, and different gases have different solubility. So everything is like not concentrated in one part of the lake. It's distributed and is unevenly produced, and you have methane here and here not. So I'm not exactly sure how it would be to take this methane. Also because as soon as it is in contact with oxygen, it is oxidized, so it's degraded. And even in the water column, when methane is released from the sediments and is going up in the water column to the atmosphere, sometimes it's already oxidized by bacteria. So not all methane that is produced is released to the atmosphere. It really depends on the mechanisms. If the lake's shallow, it's easier. If it's really deep, it's a bit tricky because of this oxidation. So yeah, it's really tricky to take this methane and use as energy. But of course, that would be amazing.
But can be done. It can be done.
Yeah, if we find a way to take it, you could use methane as a source of energy, of course.
Ashish, is there any question, or otherwise everybody is requested to come start their video so that we can take a one group photograph? All attendees are requested to start their videos.
Also, if you find yourselves with any questions later, you can just email us and we'll happily answer.
Yeah, sure. I think Prashant, now it is over to you.
Yes, sir, sure. Hello, Ritvik. Hello, Aditi.
Hello. Hello.
I'd like to thanks everybody on behalf of IPA. Good afternoon to all attendees who are there in India. Good evening to all attendees who are there in India, and good afternoon to all one who are there in Germany, because it's afternoon there. Firstly, I'd like to thank Juliana for sparing a valuable time and sharing such a valuable knowledge with us. The session was wonderful. I think everybody has enjoyed the session. It was full of knowledge. Thank you very much, Juliana.
Thank you. You're welcome.
I also like to thank Ishre for sharing hands with us, Triple ID, all the architects, those who have joined us, all my friends, all other attendees who have spared some time for such a valuable session of leg therapy. I also like to inform you, we are coming up with one more session. It will be most probably on, Ghime sir, it will be on 18th?
It is on 19th.
It is on 19th, and the topic will be the water architecture. We will definitely share the link to all those who have attended today. Even that topic is beautiful, water architecture.
It will be more interesting.
Sorry, sir?
It will be more interesting.
Yeah, it will be more interesting because topic itself is more interesting. So definitely the content will be like a knowledge gathering one. Lastly, I like to thank Microsoft team who has given us a platform to make this webinar possible. Thank you. Thank you everybody for joining us. Thank you very much.
Thank you. Thank you everyone.
Thank you very much for organizing.
Thank you.
I request everybody to take care of yourself, your family in this pandemic situation of COVID-19.
Yes, take care. Stay healthy.
Thank you. Take care.
Bye.
Take care.
Thank you.
Bye bye. Thank
Take care.
you.
Bye.
Thank you.
Thank you.
Yep.
Hello. एकदम excellent. अरे, but anyway, whatever was there, it was good, and it would have been more. Topic was good. It was taken very well. आपला हा पटकन निघून गेला कोण? त्याचं व्हिडिओ रेकॉर्डिंग कुठे आहे? ते पाठवायचे ना तिकडे. हाँ शिट लगातार. हाँ नहीं तुम्ही आहे. आय एम स्टिल ऑन दी दिस वन. नाही तसं काही नाही आहे. आता अजून स्टिल 8 पीपल्स आर बॅलन्स देअर. मी फक्त इथे व्हिडिओ रेकॉर्डिंग कुठे आहे तर व्हिडिओ रेकॉर्डिंग गायब झाली असं नाही मला पाहिजे. येस येस बोलतो मी त्याच्यात. हा हो येस यशवंत हाऊ आर यू? You are mute, I think so. विश्वास, अरे ये कहाँ गया?